dear students, welcome to Easy BTech, your guide for BTech and beyond. This channel is very helpful to you to understand BTech subjects very easily. And today's session, we are going to see properties of Laplace transform. Very important topic or session. So please follow. Let's start today's session, properties of Laplace transform. So in this, we can discuss one by one property. So topic, properties of Laplace transform. Properties of Laplace transform. Okay. So the first property, linearity. The first property is linearity. Every property we discuss the statement or definition. After that, we can do proof also. So what is linearity property saying? If x1 of t Laplace transform is x1 of s. For x1 of t, the Laplace transform is x1 of s, and ROC of this is R1. x2 of t Laplace transform is x2 of s, x2 of s, and ROC of this is R2. Then A x1 of t plus B x2 of t, linear combination of x1 and x2, this is called. So this total Laplace transform is A x1 of s plus B x2 of s, and ROC is, for this combination, the ROC is R1 intersection R2. Intersection means common of R1 and R2. Right? Let's see the proof. So this proof we can do easily by the Laplace transform formula. So most of the properties are proved with the help of Laplace transform formula. Let's write that formula first. Laplace transform formula. So proof we can do using formula. Laplace transform of a signal x of t, we can indicate like capital X of s, which is equal to integral minus infinite plus infinite x of t into e to the power minus st dt. So here the formula is saying that if you understand the formula, we can do proofs easily. Whatever the signal here x of t, that is here. So integral minus infinite plus infinite, the signal x of t e power minus st dt. Now we are going to take A x1 of t, B x2 of t Laplace transform. This is the signal now, linear combination of x1 and x2. So Laplace transform of A x1 of t plus B x2 of t. Its Laplace transform is equal, how to write? The same way, integral minus infinite plus infinite. Here the signal A x1 of t plus B x2 of t. B x2 of t into e to the power minus st dt. So here what I did, whatever the signal we are taking, that I am placing or writing in the place of the signal. Here x of t is the signal, x of t is here. A x1 of t, B x2 of t is the signal. So here A x1 of t plus B x2 of t. Just you separate here. We have plus and we can write separately. So integral minus infinite plus infinite, A is a constant or a scalar, you can write outside, and x1 of t into e to the power minus st dt. This is the first one. Plus B is a constant, we can write outside, integral minus infinite plus infinite, x2 of t e to the power minus st dt. Right? And by observing these integrals, they are like Laplace transform formulas, right or not? Compare Laplace transform formula and this integral. The first one indicates A x1 of s, and the second one indicates, second integral is x2 of s into b. So this is the proof. That's all. A simple proof. Totally formula we need to understand well. That's all. Let's go to another property, time shifting property. Time shifting property. Time shifting property. Time shifting property. First we write the statement, then we go for proof. So what is it is saying that time shifting property means if x of t Laplace transform is x of s. This is the Laplace transform pair, representation of Laplace transform pair. What is time shifting property? X of t minus t naught Laplace transform. So time is shifted. Here t, now it is t minus t naught. So the Laplace transform is x of s into e to the power minus st naught. E to the power minus st naught. Okay. And here ROC is R, and x of t minus t naught ROC is also R. There is no change in ROC, the same ROC. Let's see the proof now. But the proof is same Laplace transform formula. First we take Laplace transform of x of t is x of s, which is equal to integral minus infinite plus infinite x of t e to the power minus st dt. Right? Let's have x of t minus t naught Laplace transform. So Laplace transform of x of t minus t naught. Laplace transform of x of t minus t naught. So how to write its Laplace transform, x of t minus t naught Laplace transform? How to express or how to write? In the same way, x of t Laplace transform. So in the place of x of t, now x of t minus t naught. That's all. The signal is x of t minus t naught. The same thing we are taking here, x of t minus t naught and e to the power minus st dt. That is as usual. So let this difference t minus t naught is equal to p, variable p. By this we can write t will become p plus t naught, and from this dt will become dp. T naught is a constant. And what about lower and upper limits? And if you discuss lower limit, so p is equal to t minus t naught, t lower limit minus infinite, so minus infinite minus t naught is equal to p. That implies p is same minus infinity. And upper limit, what about upper limit? Infinity minus t naught is equal to p. This become plus infinity, right? So all these we are going to substitute in the above integral. We are going to write all these, then we can have answer. So if you go to next step, just a substitution of all those. So is equal to lower limit is same, minus infinite, upper limit also same, and x of t minus t naught, what is t minus t naught? P into e to the power minus st. What is t here? P plus t naught. So here p plus t naught, p plus t naught, dt is equal to dp, right? So here integration is with respect to p. So only p terms will be inside the integral. Remaining we can write outside e power minus st naught, so which is outside, and the remaining integration is same, minus infinite plus infinite x of p e to the power minus sp dp. So if you observe this integral, it is like Laplace transform formula x of s, right or not? See here x of s formula, here p, here t, everything is same. So finally what we can say, x of s into e to the power minus st naught. So Laplace transform of x of t minus t naught is x of s into e to the power minus st naught. And similarly we can write, Laplace transform of x of t plus t naught. X of t plus t naught. So what is the Laplace transform of x of t plus t naught? Here t minus t naught e power minus st naught into x of s. So here you get e power plus st naught. That's all. Into x of s. So this is the time shifting property. Right? Let's go to third one. Third property. Shifting in the s domain. Shifting in the s domain. Shifting in the s domain. S domain. Shifting in the s domain. So first see the statement, then we can do proof. Shifting in the s domain. So if x of t Laplace transform is x of t Laplace transform is x of s and ROC is capital R. The ROC of this is capital R. Now shifting in the s domain, that means x of s minus s naught. X of s minus s naught. X of t into e to the power s naught into t. Or Laplace transform of e power s naught into t x of t is equal to x of s minus s naught. And ROC is here. The ROC is R plus real part of s naught. This is the ROC. So e power s naught into t into x of t ROC is, this ROC is R plus real part of s naught. So let's see the proof now. The proof we can do using Laplace transform formula. The Laplace transform formula is Laplace transform of x of t is equal to x of s is equal to integral minus infinite plus infinite x of t into e to the power minus st dt. Right? Now we are going to take e power s naught t into x of t Laplace transform. So Laplace transform of e power s naught t into x of t. What is the Laplace of this total? How to write? So integral as usual minus infinite plus infinite. Here e power s naught into t x of t, this is the signal, so as it is we are taking, into e to the power minus st dt. As per formula we are following. So here exponentials are there, we can add the powers. So infinite minus infinite plus infinite x of t into e to the power, and also we can take minus common s minus s naught. In the power minus common, so s minus s naught into t dt. And if you observe this integral, it is like our Laplace formula or Laplace integral, but here s, that is why it is x of s in the e power minus, and only s is there, that is why it is x of s. So here in the e power, what we have, that will be answer. So Laplace transform of e power s naught into t x of t is equal to x of s minus s naught. And similarly, Laplace transform of e power minus s naught into t. Here what is the change? Sign minus s naught into t. Its Laplace is x of s plus s naught. X of s plus s naught. Simple, very very simple. This is the shifting in s domain. And next thing, next property, time scaling property. Time scaling property. The fourth one, time scaling property. Time scaling property. So first we discuss the property, means a statement, then we do proof. The first property is saying that if x of t Laplace transform is x of s, x of t Laplace transform is x of s, and ROC is R, its ROC is R. Then time scaling means x of AT, x of AT. What is the Laplace transform of x of AT? 1 by mod A x of s by A, and ROC also become, its ROC is also R by A. ROC is divided by factor A. So this is the ROC. Let's see the proof now. So first we take the Laplace formula. Laplace transform of x of t is equal to x of s is equal to integral minus infinite plus infinite x of t into e to the power minus st dt. Okay, let's write now Laplace transform of x of at. X of at Laplace transform is equal to integral minus infinite plus infinite, here x of at, whatever the signal that is here, and into e power minus st dt. It doesn't mean that t is equal to at. Whatever the signal x of at, that is in the place of x of t, right? Let's go to next step. So you let at is equal to p, the variable p. By this, t will become p by a, and dt will become dp by a. Okay, and lower and upper limits, if you observe lower limit, upper limit, so lower limit a into minus infinity is equal to p, so p is equal to minus infinite. Minus infinity is multiplied by a, so nothing happened to minus infinity, same limit minus infinite. And upper limit a into plus infinity, this is the upper limit, a into plus infinity is equal to p, so p will be plus infinite. So all these we are going to substitute in the above integral. We are going to write in the above integral. Let's see that next step. So this is equal to integral, the lower limit is minus infinite, upper limit is plus infinite. As usually limits minus infinite plus infinite, and x of p, so here at is p, therefore x of p e to the power minus st. What is t here? T equal to p by a, so t is p by a, and dt is equal to dp by a, dt is equal to dp by a. We can write 1 by a outside, and integral minus infinite plus infinite x of p and e to the power minus of, we can write s by a p into p dp, right or not? And by comparing our Laplace formula and this integral, we can get the answer. So here e power minus st, only minus, yes, minus is there here also, s is here, that is why x of s. But here in the place of s we have s by a, therefore 1 by a x of s by a, x of s by a. Okay, so this is a x of at Laplace transform. For example, if a is greater than 0, this will be same as usual. If a value is positive or greater than 0, 1 by a x of s by a. Suppose if a value is less than 0, negative, what will be the situation? How is the answer now? So let's take a value negative. So in this special case, a value negative or less than 0. Okay, so let's take with value we can do it. Let a is equal to, for example, minus 2. Minus 2 is less than 0 or not? Less than 0. Now the Laplace transform of statement x of t Laplace transform is x of s. Then x of minus 2t Laplace transform is how much? So we can have the answer, we can do now. So as like Laplace transform formula, so Laplace transform of x of t first we write, this will be x of s, and it is equal to integral minus infinite plus infinite x of t e power minus st dt. Okay, then we want x of minus 2t Laplace transform. So x of minus 2t Laplace transform is integral minus infinite plus infinite x of minus 2t e to the power minus st dt. So in the similar way, previously we have taken minus, or this minus 2t we can take as a p. Okay, let minus 2t is equal to p, and t will become minus p by 2, t will become minus p by 2, and dt will become minus dp by 2, and limits, lower and upper limits, lower limit will become minus 2 minus infinite is equal to p, so minus into minus plus, so p will be plus infinity, lower limit is plus infinity, upper limit is minus 2 plus infinite equal to p, by this p will be minus infinite. So this data we are going to substitute in this. So integral lower limit plus infinite, upper limit minus infinite, and x of p e to the power minus s. What is the t? T is equal to minus p by 2. So here we can write minus p by 2. dt. What is dt? Minus dp by 2. Okay. So here 1 by 2 I can write outside, right? And integral, here we can exchange the limits by removing this minus sign in integration. We can do it. So minus infinite plus infinite, and minus sign also removed because upper and lower limits are exchanged. X of p and e to the power minus of minus s by 2 p dp. We can write like this. So this is like our Laplace formula, right? So 1 by 2 x of, here in the place of s we have minus s by 2, or s by minus 2, no way, s by minus 2 also correct, or minus s by 2 also okay. So if a is less than 0, in the outside we have 1 by a, 1 by 2, right or not? So 1 by mod a we can take in the overall. So answer what is here? 1 by 2 x of s by minus 2. So minus 2. So if you go to property, so here I written 1 by mod a, because outside the a value is always positive. So 1 by mod a. Is it clear? Okay. So by this we can do time shifting property also. Time reversal property also we can do. See now, time reversal property from time scaling property. Time reversal. Very simple. Time reversal property. What is time reversal property? Is x of t Laplace transform is x of s. X of t Laplace transform is x of s. Right? Now x of minus t Laplace transform. This is the meaning of time reversal. T is minus t. So what it will be as per time scaling property? 1 by mod a x of s by a. So here a is minus 1. Right or not? So 1 by mod minus 1 x of s by minus 1, which is equal to x of minus s. Its proof we can do easily by using time reversal property. We know time reversal property. We know that as per time reversal property, time scaling property, as per time scaling property, What is the time scaling property saying? X of at Laplace transform is 1 by mod a x of s by a. So if a value is minus 1, then x of minus t Laplace transform is 1 by mod minus 1 x of s by minus 1. So this will become 1 by mod minus 1 plus 1. So x of minus s. This is the time reversal property we can do using time scaling property. Right? Using time scaling property we can do. The next one, conjugation property. The next property, conjugation property. Conjugation property. Conjugation property. See definition first, then we can do proof. If x of t Laplace transform is x of s, x of t Laplace transform is x of s. Conjugation means x star of t Laplace. Star indicates complex conjugation of x of t. It will be x star s star, x star s star. This is the complex conjugation or conjugation property. And here ROCs are same, no changes in ROC. Means x of t ROC is R, x star of t ROC is also R, same ROC. Right? Let's see the proof. Proof is from formula, Laplace formula. We know Laplace transform of x of t is equal to x of s is equal to integral minus infinite plus infinite x of t e power minus st dt. Minus st dt. Now we want Laplace transform of x star of t. X star of t Laplace transform we want. So integral minus infinite plus infinite. Here x star of t into e to the power minus st dt. So this integral I am arranging like integral minus infinite plus infinite, this x of t and e power here minus e power minus s star t dt whole star. So here s is a complex variable, right or not? S is the complex variable, right? So s star means complex conjugation of s. So this above integral we can write like this. If you apply conjugation, s star star will become s, and here x star will be obtained. So same we can get. And if you observe it, if you observe this integral, it is like our Laplace formula or Laplace transform formula, right or not? Just observe clearly. So what we can write now? Here s is there, that is why x of s. But here we have s star, that is why x of s star and whole star is there. So I am writing here whole star. This is the simple proof. Okay. So thank you students. We can discuss more properties in the next session. Thank you. Thank you all.